All right, another style of operations that we can deal with when it comes to functions is something called a composition. And so let's kind of think about this input versus output part when we deal with functions. So let's say I've got some sort of input that we're going to call x. I'm going to put that into g, and g is going to spit out some output, right? And so here we've got the input we would say is the domain of g, the output would be the range of g. Okay, now let's say then, once we've done that, we then insert the output into f. So now f's domain happens to be the same as the range of g, and this is now the in, and then we get out something from f, because f does something, and that's the range of f. Okay, now what impact is g going to have on f? What's that going to do when we take the outputs and have that be the inputs for f? Well, it sort of gives us this new hybrid function. Okay, it's what we call a composed function or a composition. So this would be f of g of x, where one is inside the other. Okay, and I don't want you to associate the letters. It's not necessarily the letters that matter. It's that there's an inner function and an outer function. So this is the inner and this is the outer. Whatever letter's there. Okay. So given two functions f and g, we can determine f of g of x. So f of g of x, that's how we say that, which means we're going to substitute g of x for all x's in f and then simplify. Okay, g of f of x which is what that bottom one says, means we're going to substitute f of x for all x's and g of x, and then we're going to simplify. Alright, so let's take a look at doing some composed functions here. Let's start with f of g of x. Given f of x is x minus 7 and g of x is x squared plus 2. So what we want to do is we want to take f and we want to insert g inside it. Okay, so if f is the outer function, then f, wherever that x is, I'm going to leave a blank. So it's something minus 7. And this is where I'm going to come and put g. So that's x squared plus 2. Okay, and then about the only thing we can do at this point is look at doing any sort of simplifying. So that would be x squared minus 5 for our end result. Alright, then we're going to go and we're going to reverse the order. So we're going to switch and put g on the outside and put f on the inside. Okay, now g happens to be something squared plus 2, and then I'm going to insert in the f function, which is x minus 7. And at this point, we can do a little bit of simplifying as well, so that's x minus 7 times x minus 7 plus 2. I can see that there's some foiling we can do, so x squared minus 7x minus 7x plus 49 plus 2. So g of f of x would be x squared minus 14x plus 51. Now, what do you notice about those two things? They don't even look close to being the same. Okay, so one observation hopefully you're making is that it does matter the order in which you approach these. That if you aren't careful and you do the wrong inner is supposed to be the outer, etc., then you end up getting the wrong function altogether. Okay, now let's look at sort of some numerical calculations. How would one calculate a value of this? And I'm going to show you two different ways to do this. One involves, we have this nice equation, let's use it. So if I want f of g of 3, then I can just insert that in this x squared minus 5. So I can just put the 3 in. And that'll give me 9 minus 5, which is 4. Okay. However, what if I haven't done all that work and figured out what the equation is? Okay, well, the other approach that we could do is we could do this step by step, so one function at a time, because I know the g function is the inner. So I could find the g of 3, which is something squared plus 2, and I can substitute the 3 in there, which gives me 9 plus 2, which is 11. And then I want to find f of 11, which is something squared minus 7, so 11 minus 7, which is 4, and notice we get the same answer. So method one simply means that we figured out what the equation is. Method two is if we haven't figured out the composed equation, then at least we can find the functional value of it. So let's kind of reinforce this with g of f of 3. So starting with method one, we have this nice lovely equation. So g of f of 3, g of f of 3. So something squared minus 14 times something plus 51. So I can put the 3 in there, which is 9 minus 42 plus 51. And then I can calculate that all out. Let's see. 18 is what I get. Alright, method 2, again, assumes I haven't figured out what the straight to it equation is. So in method 2 then I would want to do the inner, which is f of 3. So that's 3 minus 7, which is negative 4. And then I want to find g of negative 4, and g of negative 4, that would be something squared plus 2. And so negative 4 squared is 16 plus 2, and we end up getting the exact same 18 that we got doing the other method. So when it comes to this particular skill, it doesn't really matter which method you go with, just whether or not you figured out the original equation. All right, let's change f and g and make them a little more complicated. So we'll make f x squared plus 2 and g of x the square root of x minus 4. Let's first figure out what f of g of x looks like. So I like the color idea. So we'll put f on the outside and g on the inside. Alright, so f is something squared plus 2, and I want to put the square root inside there. So what happens when you square root? The symbol goes away and you're left with x minus 4 plus 2. So that's x minus 2 is our composed function. So I'll make a little mental note to myself. Let's do the same thing with g and f again, so we'll switch the order. Alright, so we want g on the outside and I want f on the inside. Alright, well, g happens to be the square root of something minus 4. And that something that I'm going to fill in is x squared plus 2. And let's see, so we get x squared minus 2. And at that point, there's not much that I can simplify, but it is worth noting that those are not the same. So again, order still matters. Still matters which direction we simplify that with. All right, and we still have our two methods for evaluating numerical forms of this. So we'll go with method number 1, where I'm just going to use the composed equation. So that's something minus 2, which works out to be 3. Method 2 is, if I don't know it, then I want to start with the inner. So g of 5. So g of 5 would be the square root of 5 minus 4, which is the square root of 1. So that's 1. And then I want f of 1, which is something squared plus 2. And again, I want to put that 1 in there. And I get 1 plus 2, which is 3. So both ways I get 3. Yay. Let's do the same thing. Let's switch the order. So g of f of 5. Let's see, I have the equation there. So g of f of 5 means I got square root of something squared minus 2. And I can just put the 5 in there. So that'd be 25 minus 2, which is the square root of 23. And then, so that would be it. That would be the square root of 23 for my composed answer. And then method 2, I want to start by finding f of 5. F of 5 would be 5 squared plus 2, which is 27. And then I want to evaluate g of 27, which is the square root of 27 minus 4. And we get the square root of 23. Yay! So you notice we get the same number both times. All right, finding functional values is great when we're dealing with an equation, but what if they've organized the information in a slightly different way? So let's say, for example, we're given a table of values of some type, and we're still asked to find functional values given this table. Okay, well, let's first make sure we understand what the table is saying to us. So this particular row right here, these are x values. So when x is negative 2, in the f function we have a 1, and the g function we have a 2. Over here we have 0. That would translate to be that f has an ordered pair of 0, negative 2, and g has an ordered pair of 0, 0. Okay. Now, in looking at our notation then, we don't have a function that we can plug into or evaluate and find the composed function value. So we're going to have to go with the inner-outer approach. So I want to start by finding g of negative 1. So I'm going to go to the x row right here, find g of negative 1, which is 1. It's that number right there. And then I want to take that and insert that into f. So I want to figure out what f of 1 is. So I go to f of 1, which is the 1 column. And I go down, and f of 1 just happens to be 1. So f of g of 1 is 1. All right, let me get rid of my little coloring scheme here. So to find f of 1, first off, yes, it is possible to do that. You can stick a function inside itself. So f of, I'm going to start with the inner, so find f of negative 1. So here's the negative 1 column, and find f, that's 0. And then I want to take that value and stick it right back in, evaluate it right back into f. So f of 0, so come over here, which happens to be negative 2. And so that's our value. F of negative 1 happens to be negative 2. Now let's take that same series of questions and let's look at a graph. So again, just a different way to organize the information. Very similar to a table approach. Just now we've got ordered pairs to actually stare at. And then we're going to do the same process. We're going to find the inner value first, evaluate that in the outer function, and see what we get. So I want f of 1. So here f is the bottom equation. So I want to look to where x is 1, and right there. So I want that number, which is negative 1. And then I want to evaluate the g function of negative 1. So I come over to where negative 1 is on the x-axis, and that's my ordered pair for g. So there's my answer, is 3. Okay. Now I want f of g of 0. So I start with the inner, so I start with g of 0. So I go to 0 on the x-axis, go up to g, and there's not a defined ordered pair, but I can see that it clearly crosses at 5, so it's got to be 0, 5 for that ordered pair. So 5 would be the y value. And then I want to take that 5 and evaluate that in the f function. So I come over here to 5 on the x-axis, go to where f is, which is this ordered pair here, and I want the y value out of that, which is 1.